Now I am going to discuss the concept of empty sets, which is section 1.3 of chapter 1, class 11. Section 1.3, empty sets. What are empty sets? What are empty sets? Before going to the definition, let us discuss some examples of sets. Consider the set A equal to set of all x such that 1 less than x less than 2 x element of n. What does it mean? A is the set of all natural numbers lying between 1 and 2. Which are the elements of this set? No element. There is no natural number lying between 1 and 2. So, there is no element in the set A. This is an empty set. Empty set is a set which contains no element. A set containing no element is called an empty set, which is denoted by this symbol or phi. These are the two representations of the set empty set. Here A is an empty set. Another empty set, let us consider B equal to set of all x such that x is a negative natural number. X is a negative natural number. Is there any negative natural number? No. Natural numbers are all positive numbers. These are all examples of empty sets. So, empty set is a unique set. It has no element. And the representation of empty set is these two symbols. These brackets and phi are the representations of empty set. Empty set is also known as null set or void set. So, empty set, null set or void set. So, the next is finite or infinite sets. Section 1.4, finite and infinite sets. Finite and infinite sets. Finite sets are sets with only finite number of elements. It may be a null set. Null set is a finite set. It may be a null set or a set with only finite number of elements. Let us consider a set. Set is equal to 1, 2, 3, 4, 5, 6. This is a finite set because it has only finite number of elements. B is phi. Phi is a finite set with no element. So it is a finite set. Then let us consider another set. Set of all x such that x is a real number. X is a real number such that x square less than or is equal to 4. X is a real number such that x square less than or is equal to 4. Is it a finite set? No, it is not a finite set because I said here is x is a real number. If this is x is a natural number or x is an integer such that x square less than or is equal to 4, it is a finite set. If I take the set D is equal to set of all x such that x is an integer such that x square less than or is equal to 4. Which is the set? -2, -1, 0, 1 and 2 are the elements of this set. These are finite number of elements. But when I change these integers to real numbers, what are the elements of this set? We don't know. There are infinite number of elements with its square less than 4. So this is an infinite set. We cannot count, or there is an infinite number of elements in this set. This is an infinite set. Here D, A, B and D are finite set and C is an infinite set. So a set with only finite number of elements or no element is called a finite set, and all the other sets are called infinite set. A set with infinite number of elements are called infinite set. The example of infinite set, let us consider set of all natural numbers. It is an infinite set. Set of all real numbers, it is infinite. We cannot count the elements of real number set. So it is an infinite set. Set of all rationals are also infinite. So they all have infinite number of elements. One thing is noted that all infinite set cannot be listed in, or all infinite set cannot be written in roster form. So set of all real numbers we cannot write in roster form. But set of all natural numbers, set of all integers, all we can write in roster form. So all sets cannot be written in roster form. So it's all about